Hey guys, this is part 2 of our lesson. We've already done problems 1, 2, and 3, and we are learning how to use tangent, sine, and cosine to solve a variety of problems. So if you missed these lovely problems, don't they look interesting? You might want to go back and check out the first video. Now, I'm assuming that you have memorized these three formulas. If you have not memorized them, pause the video and memorize them right now. If you're having trouble remembering the relationships, use the shortcut, this special word, magic word if you will, Sohcahtoa. It helps you remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But it puts it all in one word, Sohcahtoa. Problem number 4 says, draw a line that goes through the origin. Okay, so the origin is right here and has a slope of 2/3. That's rise over run, up to right 3. So if I go up to right 3, up to right 3, this is the line that they are talking about. So I think I'll just go ahead and draw that line on camera because I can do it real quick. Alright, there's the line that they asked us to draw. Now find the angle formed between this line and the x-axis. Okay, so you know what? I might as well draw a whole triangle. So here's the x-axis, and while I'm at it, let's go ahead and make a right triangle out of it. Okay, so we are supposed to find the angle formed between the first line and the x-axis. So I'm going to put an x inside of here because this is the angle that we are supposed to find. So what do I know? I know the bottom leg of this triangle because I can count these units. This is 1, 2, 3, 4, 5, 6. Alright, so this is 6 units across and it is 4 units tall. I'm just counting the squares. So I know those sides of the triangle. So I think it's time to go ahead and solve for the angle. The way we solve for a trig problem, we always do the same thing. Start by circling the angle. Now we're not given any of the angles. I mean, we know this is 90 degrees. But we're not given either of the acute angles. So I'm going to pick this one because that's what we are trying to find. Now we can label the sides of the triangle. Always start with the hypotenuse, which is going to be across from the 90-degree angle. So that makes this the hypotenuse. So the other two sides must be opposite and adjacent. Across from the angle is always going to be the opposite leg. Right next to the angle is always going to be the adjacent leg. So now we have to decide which trig function are we going to use. So think the magic word. Sohcahtoa. To decide which trig function we're going to use, sine, cosine, or tangent, look and decide one of these 3 sides is useless. It's not helping us at all. The adjacent leg is useful because we know it is 6. The opposite leg is useful. We know that it is 4. The hypotenuse in this problem is not useful. We don't know what it is, and it's not something that we are trying to find. So the hypotenuse is useless. So notice the sine function and the cosine function both involve the useless, worthless hypotenuse. Throw that garbage out. It's not helping anybody. Tangent is the one that's going to work for us this time. So let's set it up. Tangent, of course, is opposite over adjacent. That's what TOA is telling us. the next thing we put is the angle that we circled. So we will say tangent of x equals opposite over adjacent. So that's going to be 4 over 6. When the variable is inside the trig function, that's when you have to do the inverse trig function. So x will equal the inverse tangent of 4 over 6. And this is something we can simply put in the calculator. So second tangent gives us inverse tangent 4 over 6. So that's 33.690 degrees. All right. 5A. There are two wires connected to the top of this cell tower, one on the left, one on the right, to secure it in strong winds. The wire on the left is 217 feet long. They already have that labeled for us. And it is attached to the corner of a building that is 28 feet tall, as you can see. If the angle of elevation from the building to the top of the tower is 32 degrees, they have that labeled as well, then how tall is the tower? Okay, so we need to find the height of the whole tower. However, let's start by finding the following. Because I need a right triangle happening. And see my 32 degrees. I see a right triangle right here. Okay, if I drop it here. Now notice the side that I just drew does not go all the way to the ground. So if I find the length of this red side that I just drew, I'm going to have to add the 28 on to get the total height of the tower. So don't forget about the 28 because this doesn't quite go all the way to the ground. So this is the right triangle that we're about to solve, and specifically we're solving for this side over here, and then we'll have to add on the 28. So let's go. Step 1, circle an angle. This is the only angle that's labeled, so I'm picking this one. Now we can label all of the sides of the triangle. Always start with the hypotenuse. The hypotenuse is going to be the one that is across from the 90-degree angle. That makes this the hypotenuse. Now let's label the other two sides. Across from the angle you circled is always going to be the opposite leg. Right next to the angle you circled is going to be the adjacent leg. Now we have to decide which trig function we're going to use. And to help us decide, we will write down the magic word, Sohcahtoa. Sohcahtoa reminds us of the definition. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Sohcahtoa. So, to help us decide which function we're going to pick, decide which one of these sides is not helping us to solve the problem. Which side is useless? Well, I like the hypotenuse because we know what it is. It's 217 feet. I have to keep the opposite leg because that's what we're looking for. That's the x. The adjacent leg is over here just doing absolutely nothing. We don't know what it is, and it's not one of the things that we're trying to find. The adjacent leg is useless. So, notice how the adjacent leg is involved in cosine and tangent. That means these two functions are going to be useless. The sine function is the only one that does not involve the useless adjacent leg. So here we go. Let's set it up. So sine is opposite over hypotenuse. That's what the so part of Sohcahtoa tells us. So we will set it up sine, and then goes the angle. So sine of 32 is equal to opposite over hypotenuse. The opposite side, that's x. The hypotenuse is 217. When the variable is in the numerator, that is when you multiply by the denominator. Alright, because these will cancel each other out. And that gets x by itself. So we can just put this in the calculator, and we'll just type in 217 sine 32. Okay, that is 114.992. Okay, and this is feet. Okay, so that is x. That is x. But that is not the full height of the tower. One more time, notice that x does not reach all the way to the ground. We need to add on this extra little bit right here. And that extra little bit is 28 feet. Okay, so we need to take x and add 28 for the full height of the tower. Okay, so if I take this and I add 28, then that's 142.992. Okay, because there we added the 28. And that's the height of the tower. Part B. Part B is about the other wire. The other wire is connected to the ground 125 feet from the base of the tower. How long is this wire? So I think we're going to have to use the information that we found in the previous problem. We're going to have to use the fact that we now know the height of the tower, and we're going to use that to find out the length of the wire. So here's a diagram representing this situation. We are being asked for the length of the wire. Alright, this red length represents the height of the tower. This is the wire going to the ground. We want to know how long it is. It's 125 away from the base of the tower. And in the previous problem, we found the height of the tower is 142.992 feet. So, it's tempting to try to use Sohcahtoa once again to solve this problem. But that would be foolish, because we don't have any angles to go on, and we're not being asked to find the angle. So Sohcahtoa is not going to help us this time. But there's something even older than sine, cosine, and tangent, something that you've known previously, something called the Pythagorean Theorem. If you have two sides of a right triangle and you're trying to find the third side, your best option is to use the Pythagorean Theorem. Leg squared plus leg squared equals hypotenuse squared. I know you might have learned a squared plus b squared equals c squared, which is true only if you make sure that the c is the hypotenuse. Okay, so make sure that's true. So that's what I'm going to do. 142.992 squared, okay, plus 125 squared is equal to x squared. Okay, now I can break this down into pieces, and maybe I will, but I really want to teach you guys a shortcut. Maybe I'll show you at the end, just in case you can't handle it. So if I do 142.992 squared, Okay, I'm going to get this. So now I've got, up, it went away. My memory's not that good. 20446 71206. Okay, now I'm going to do 125 squared. So that's 15625. And all of that is equal to x squared. So I need to add these two numbers together. So I will do that. So I get this number, 36071. .71206. And that is equal to x squared. So now I need to take the square root of both sides in order to figure out what x is. Okay, so I need to take the square root. So I hit second square root. And here's my answer, 189.926. I had to round up. And this is in feet. So this is my final answer that I was looking for. Now, I was mentioning a shortcut that I would prefer to do. So let me take you back to the very first step when we had the Pythagorean theorem set up. I can take the square root of both sides right then. So rather than squaring each of these and getting all of these numbers, what I really prefer to do is to take the square root of both sides in this form. This will immediately give me x by itself. And all of this can be put into the calculator. It saves me all this typing. So this is how I prefer to do this problem. I will do the square root, and then I will do 142.992 squared plus 125 squared. Alright, you can just type in all of this at once. Okay, and you're going to get the same answer that you got after doing all of this extra work. So, if you can handle it, this is better. Well, quicker. Alright, in the final problem, they want to know now, what angle does this second wire form with the ground? They want to know this angle right here. So, I think I'm going to recopy this diagram down here. So I'm going to start with the same exact diagram that we had last time, but now instead of trying to find the length of the wire, we're trying to find this angle that it forms with the ground. So let's just begin our process. First, you circle an angle, and I'm going to circle this one for sure because that's what we are trying to find. Next, you label the sides, starting with the hypotenuse, which is always across from the 90-degree angle. So this is the hypotenuse over here. Now we will label opposite and adjacent. So look at the angle that we circled. Across from the angle is always going to be the opposite leg. Right next to the angle that you circled is always going to be the adjacent leg. Now it's time for a decision, and we will use the magic word once again, Sohcahtoa. Sohcahtoa, which of course helps us remember these important definitions. Sohcahtoa. To help us decide which one of these three trig functions to use, sine, cosine, or tangent, let's decide which one of these three sides is not actually helping us at all. The adjacent side is helpful because we know the length is 125. The opposite side is helpful because we know it is 142.992 feet. The hypotenuse is not helpful at all. We don't know what it is, and it's not one of the things that we're looking for this problem. So the hypotenuse is wasting our time. So look at the formulas that involve hypotenuse. Sine and cosine are both using that useless, worthless hypotenuse. So that leaves tangent as our hero for this problem. Opposite over adjacent, using only good things that will help us. So let us set up the tangent function. So we will say the tangent, then goes the angle, even if it's unknown. Alright, this is the angle that we circled. Angle goes inside. And then opposite over adjacent. That's going to be, alright, better make this line longer. The 142.992 over 125. Opposite over adjacent. When you're looking for the angle inside the trig function, that's when you do the inverse trig function. So x will equal the inverse tangent of all of this. Okay, and we're just going to put all of this in the calculator. So inverse tangent, second tangent, 142.992 over 125. So that's 48.841 degrees. Alright, and that is it. That is the angle that the wire forms with the ground. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.